Rajupalepu.
Can somebody bring up the slides? Yeah. Which way is the? Yeah, you can press anywhere. Good afternoon, everyone. So we'll today talk about autonomous driving from fiction to reality. And I didn't put an agenda slide purposefully because it's a vast topic and then there are so many items within that. So we'll cover some of that from technology perspective, from regulation perspective, where we are, and as Stellantis, what are we doing to make this as a reality. Okay. So if you see on this slide, I mean, so this was the fiction where many years ago, even in the movies, you would have seen people playing scramble, sitting inside the car without a driver. And today, we are talking about most of it becoming a reality. So if you look at the timeline, this is not something new. This has kind of started in 1400s. So Leonardo da Vinci actually created or actually drew one of the first self-propelled cart. So this was the origin of kind of autonomous driving, you can say. First radio-controlled car, I'm not talking about the toy cars, radio-controlled full-fledged car that was created in 1925 using a radio-controlled frequency. We as Stellantis, we have created our own full-fledged version of Citroën brand DS19 car in 1966. So this used the magnetic cables. I mean, so there's a lot of investment that was required. I mean, so under the road, you need to have the magnetic cables, and under the car, you need to have the sensors. So the idea at that time was from point A to point B, without a driver, if you are able to take the vehicle, that's kind of classified as an autonomous driving at that point in time. So today, that paradigm has changed. With the invent of the neural networks, I mean, so which has come into 1998, that's where the kind of equation got changed. I mean, so if you, those of you familiar with machine learning, you would have seen neural networks is another classification algorithm that we use broadly. Neural network kind of creates that image-based classification, which is widely used in today's autonomous vehicles. And again, 2009 onwards, most of you know, so there's a lot of cars, including Tesla, all the majors, they have started investing in autonomous driving technologies. So how does it classify? I mean, so if you look at it, the Society of Automobile Engineers, they basically classify this into 5 levels from 0 to 1. 0 is no automation. The first one is driver assistance. Then if you go into level 2, which is partial automation. So most of the cars today that are existing, which claim to be autonomous, are at level 2. So nobody's at level 3. Even including Tesla's autopilot car, which you might have heard, is actually a level 2 automated car. One company which claimed that they have created a level 3 automated car is Volkswagen's Audi A8. They claimed that they have achieved level 3 automation, but as per standards, it will still classify under level 2. I mean, so it's in between level 2 to level 3, but not a full level 3 car. I mean, so today, technically speaking, there is no level 3 at this point in time. So we have most of the cars falling into level 2 autonomous driving. From 3 to 4 to 5, these are all system monitoring. So there's no human intervention required. So that is how these are classified. This is just to give a perspective in terms of what these automation mean, and then what do they accomplish in each of these levels. So here, we just want to bring a technology perspective as well. So if you see, just like any of us who are driving the car, for the car, the sensors or the microprocessors, there are three varieties of them. One is the sensors, which are actually sensing the surroundings, the objects. The second type of chips are processing chips. These are called as the brain of the car. The third one is the control chips, which are actually the heart of the car. So these are the three varieties of chips which will enable autonomous driving in today's scenario. There are various issues in terms of creating these chips because there's no standardization today. Each one has their own specifications. It takes a lot of time to create a microprocessor. We will talk about it in a different session, but that's a different story. But just to give you a perspective, so today the maximum lead time for an automobile maker is in terms of getting the right chips that are required for achieving the right automation. And it's not so simple that you can make a processor just like any other manufacturing element. It takes its own time in terms of curation, the layering that need to happen, and even Russia, just to give you another example there, Russia-Ukraine war, you won't be imagining that that has impacted the supply chain of microprocessors. Why? Because Ukraine is the largest producer of neon gas. Around 50 to 55% of world's neon gas comes from Ukraine. And because of the war, that's kind of hampered. That supply chain is hampered, which is impacting the production of these microprocessors. So these are all the elements that are involved in creating these chips. So what are all the key challenges, right? I won't go into each one of them, but if you look into the key challenges, the sensors, which are actually the eyes, it's like if the sensor is not working, you are driving the car with your eyes closed. It's as simple as that. So the sensor need to have the visibility to a certain extent. The weather conditions will impact it. So there are so many parameters which will actually, like fog, heavy rainfall, or snowfall. These will impact the visibility, the eyes of the car. As humans, you might probably drag it to a side and then keep it there. But as autonomous driving, so there's no driver, they really need to function all the time. So how do we come over this challenge is the biggest impediment as of today. Computational performance, real time, so much of data that need to be processed today so that to make these decisions happen at split seconds and then really make it happen, right? Training models. If you look into any of the data that is available today, the real-time data is very, very less. The data sets are very, very less. But if you really need to test your scenarios, you depend on simulated data. So there's only so much that you can do with the simulated data. So you need real-time data. It's going to take time. It's going to take time for the algorithms to pick up this data, come to an accuracy levels. In other scenarios, we can probably compromise on 90 to 95% or 99%. But here, you cannot. So you need to have more than 100% of accuracy. So that's the kind of dependency that we have on the data sets that we are dealing with. Again, so I'll quickly touch upon the intuition and instincts, right? So I'll cover this with an example. So let's say you are driving on a road, and a ball pops up on the road. What will be your immediate instinct or intuition tell you? Saying, OK, so there is a child which is going to run after the ball. So you will slow down, you will brake it, and then you will probably look at, OK, so let the child come pick up the ball and then go back. So this is the human intuition. That's how it works. In the autonomous, it will not work that way. So it is an object as far as the computer is concerned. The object has passed by, so there is a clear road. Press on the acceleration. Then the boy comes, sudden reaction. That split-second reactions need to happen at that time. So this is one classic example that you might have heard in many places. So the second one that a lot of people who are actually attending these autonomous companies interviews that they will give you, there is a road which is on the cliff, and it has only one single lane. When I say one single lane, it's only one car that can go. There is a car that is coming down the hill, and there is a car that's going up the hill. What happens in the midpoint? Because they are dependent on the sensors and the lanes that are demarcating the road, both of them will come to a loggerhead. So there's no, whereas if it's a human, they'll go a little off the road this side, and then they will make the way. You might have seen this in Himachal Pradesh or even on Gachibowli roads, you can see somewhere. So this is how it happens in reality. For a computer to achieve that level of intelligence and that level of intuition, that is where the challenges are. That is where we are saying 3, 4, 5 automation is going to a lot of time. So it's not going to be so easy at this point in time. So some of the technology imperatives, right? So I won't touch all of them, but I will definitely touch a few of them. In today's architecture, each car, each company has their own specifications, has their own microprocessor specifications. There is no standardization. The software that we use, the electrical and electronic components that we use are different from manufacturer to manufacturer. This is another reason why most of the OEMs today have these delays in terms of deliveries, right? So that is how it happens. Edge computing. The biggest advantage of edge computing is today, on the fly, at real time, you can deal with data, process it, all that can happen at real time. But you need so much of computing power on the car at that time. So it needs to happen in split seconds. What is the other technology that's coming up now? I don't know how many of you know this technology called V2X. So it's vehicle to everything. And so it has a vehicle to vehicle component, vehicle to infrastructure component. So how does it work is, V2X actually leverages the technology outside. So in the sense, so on the road. So the technology that is inside the car, if you are able to connect with V2X technology, which is working outside the environment, if we can combine these two, we'll be able to solve some of these high computing problems today. HMI, so the customer experience, human-machine interface. I'll quickly give you an example. So if you have seen a traditional remote of a TV or on a Tata Sky remote, you see so many numbers, so many buttons. So it's full of buttons. But if you look at your new TV remote, so which is coming from either Samsung or Amazon's remotes, it has only one wheel and then 2 buttons. It has simplified your user experience so much that at some point in time, so you didn't ask for it as a customer, but they kind of invented this for you. So these are the changes that need to happen, because the human interface and the customer experience inside the car, Daimler claims they have the best customer experience inside their car, but their systems are very, very proprietary. So they're only somebody who is joining them need to learn and then implement. But today, every company is doing with a lot of third parties, and then a lot of third-party products are getting integrated. So that level of integration and standardization, if it can happen, that will give you better customer experience. Cybersecurity. This is one of the biggest threats that we are facing today. Imagine these are all sessions that you have in the car. And then imagine some hacker is taking control of your car while there is no driver. So you can imagine, so how the car will behave and then where it can go. Biggest threat today. So unless we solve this, and then there are some regulations around this is going to take some time. So this is another regulation point of view we just want to cover. So if you look at US alone, federal government has a regulation which is for the nation. And the 30 states in US, each of them have their own regulations. So these are the amount of regulations that you are dealing, especially in the autonomous space. So there's so much of, but what is happening with that is each of them are formulating the regulations, which is why you see on the bottom I've said, in the last 2 years, the regulations are becoming more and more faster as compared to the technology that need to go into the car to make this as a reality. So this is the reality, ground reality today. The other one, liability factors. Who is liable in case of a crash? So I put few names there, but I'll give you an example which has actually happened in Arizona. I don't know whether it is 2019 or 2020. Uber was testing this with a technology called LiDAR. So with the technology LiDAR, if you look at a car, so it will look like a jammer machine that goes into Prime Minister's convoy, right? I mean, so that's the kind of car that you will see. There was a driver inside. They were testing the level 3 to level 4 automation. The person who actually released the car on the road, he thought there is a driver inside who is going to react in the emergency scenarios, disabled the emergency braking system. And the person who is sitting inside the car, who is the driver, he was actually, this is again, I read somewhere, I mean, so, looking at Facebook. There was a lady suddenly crossed, and the speeds were only 30 miles per hour, because in testing environment, you can't go beyond 30 miles per hour. The car hit the lady, and the lady died. This is actually happened. So it went to the court. Who need to be blamed? Is it Uber? Or is it the driver? Or is it the person who disabled the emergency braking system? Or is it Mark Zuckerberg who gave the Facebook to that person? We don't know. So these are the liability factors that are involved in today's scenario. I mean, so this regulation, unless this is formulated, we will still have challenges around this. Key ecosystem players, I mean, so as you can see, there's a wide variety, right from OEMs. This is where we belong to as Stellantis. But our suppliers, chip manufacturers, technology companies, map providers, solution providers, and integrators. Integrators play a major role, by the way. Going forward, I mean, so they would be having a lot of role in this. The government and DOT companies. With the invention of 5G, some of the technology challenges in terms of getting the real-time data and then processing is relatively easy. But these are all the players that need to work together. So today, that is the biggest challenge. I mean, so in some cases, there is good amount of collaboration. In some cases, that's not. But unless this happens, we will not be able to really see a fully autonomous car in the near future. What are we doing as Stellantis? So we have our own platform, which is called as AutoDrive, Stella AutoDrive. In terms of achieving the level 3 capabilities, we have partnered with BMW. So this is where I was also earlier alluding to, saying the industry collaboration and working together. I mean, so we have partnered with BMW for that. For the level 4 and above, already Waymo is the leading player there, Alphabet's Waymo. We have partnered with Waymo in terms of getting into level 4 and above. We have also acquired a company called AI Motive, which is actually a technology company which is providing various components in terms of, especially in the autonomous driving space. So way forward, as I was mentioning, infrastructure, investments on the road infrastructure, physical infrastructure that is required. I mean, so the lane markings, surface distress, everything need to be proper because I mean, so there's no human which is there inside the car. Then cooperation and competition or co-innovation, which is what we talked earlier in my earlier slide, in terms of regulations as well as legislations, right? I mean, so if we are all looking at this collectively, I think we will be able to make this as a reality. But level 3 is something that we will be able to achieve in the near future. Level 4 and 5 will take time, but this will also become a reality. So I just want to give you this perspective of how this whole autonomous driving space is moving. Thanks for active listening. And I close here. I mean, so if you have any questions, feel free.
Yes, we can clap for that. And now, ladies and gentlemen, if anybody has a question, please feel free to raise your hand. We can just, okay, we have somebody, sir, over there in the blue shirt. Sir, can you please stand up so we can just hand over the mic to you? Yeah.
Thank you. And I'm Bala from TCS. So thanks for the wonderful presentation. My question is, what is the role of 5G in the context of the autonomous driving? And how do you see this will accelerate the autonomous driving and make it more real in the mainstream?
See, as I have also explained earlier, right? I mean, so there are physical components like your radar, sensors, microprocessors, which are actually getting all the data. but there is also the computing that is required at real time, and the right algorithms that need to process this data. And so we talked about edge computing. We talked about V2X technologies. How do you integrate and then make the right decisions and then get the accuracy to the level that autonomous driving requires, right? I mean, so this is where IT plays a major role. And your experience. And so your experience all is software, right? I mean, so apart from the hardware components, there's a lot amount of software. I mean, so today if you look at a car, it's mostly a computer on wheels. So it's less of a ICE engine. I mean, so going forward, you might not even see ICE engines. I mean, so you might see electric engines. I mean, so that's how the technology will move.
So you see that autonomous driving vehicles becoming real only with the possibility of the network latency going down with the help of 5G and 6G?
The initial tests, at least on 5G, are giving a lot of hope that the latency will not be a problem. I mean, so we'll have to do a lot more experimentation before we can confirm that latency will not be an issue going forward. But as of now, 5G is very promising.
Thank you.
All right, so with that, we can get back to the questions. It's just that we're running short of time, and sir will be here, so we can have a one-on-one later on. I request, yes, Dr. Chetan Samant to please step forward and present a small token of appreciation. And we can also take a photo. Yes, this can be a photo opportunity.